17. Is marriage obsolete? According to a study done by the Pew Research Center, 39 believe that marriage is now obsolete. Wow. Suppose a random sample of 500 adult Americans is asked whether marriage is obsolete. Describe the sampling distribution of p hat. Well, I know p is 0.39. The sampling distribution is approximately normal, with mean 0.39, standard deviation 0.39 times 0.61 over how many? 500. Okay, and why is this normal? This is approximately normal if random samples, and 2 if NP, which is 500 times 0.39, is greater than 10, which it is, and NQ, which is 500 times 0.61, greater than 10. Alright, so there's A. Okay, B. What's probably the random sample of 500? Less than 38 believe. Delta is 38%. After a while, these all kind of seem the same, don't they? So this is going to be probability of p hat is less than or equal to 0.38. Do normal CDF, and you should get, look at the answer right here, looks like 0.32. I'm going to go ahead and do it. I'll do it for you right here. Oops. Okay, not wanting to come on here. There we go. Okay, so we're going to do normal CDF, a really small number, the upper bound is 0.38, mu is 0.39, and this is going to be square root of PQ, 0.39, oops, times 0.61 divided by 500. That's going to be 32, oops, 0.33%. C. What's the probability that between 40 and 45% believe it's obsolete? Between 40 and 45. So that's a probability that 0.40 less than or equal to p hat less than or equal to 0.45. And again, that's normal CDF. Just find the area between them, and you should get 31.98%. And D. Would it be unusual for a random sample to have 210 or more? Well, 210 over 500 is, doing it on the side here, 42%. Okay, so now we're looking at 42% or more. So that's the probability of p hat is greater than or equal to 0.42. And if you do normal CDF on that, you get 8.38%. So is that unusual? No, we don't usually say you get unusual till like 5%, which is 1 in 20. 10% is 1 in 10. So that happens, but so we say not really unusual. All right, 20. Having children, 18% of women 40 to 44 have never given birth. Okay, so P is 18%. Oops. A random sample of 250 women from 40 to 44 have results in 52. Have results in 52 indicating they have never given birth. Okay, So p hat would be 52 over 250. And that's 20.8%, 0.208. Explain why this is not necessarily evidence that the proportion of women 40 to 44 years who have not given birth has increased since the time of the Pew study. Well, if I look at the sampling distribution, mu sub p hat is 18%, sigma sub p hat 0.18 times 0.82 over 250. And we're basically saying, hey, what's the chance that I get a sample of 250 and have them be 20.8% or more? Does that make sense what they're asking? They're saying, what's the chance that it's increased since, from 18%? Well, we got a sample of 20.8%. So what's the probability that it's greater than that? Or equal to 208? And if you find that probability, you get 12.51%. That's not unusual, right? So this could happen. If the true mean is 18%, me getting 20.8 or higher happens 12% of the time. So yeah, that's reasonable. It doesn't make me question the 18% at all. And last but not least, number 21. Exit polling. We want to determine the outcome prior to results being tallied. Referendum to increase funding for education is on the ballot in a large town. Exit poll of 310. 310 find that 164 of the 310 voted for. So that's my sample. Well, 164 divided by 310 is 52.9%. So 52.9% in my sample voted for. Okay, that's a point estimate. How likely the results of your sample if the population proportion of voters in the town? So if the town really favors, or the percentage really favoring it is 0.49, how likely is that to happen? Well, let's look at the distribution of samples of size 310. If I take all those samples, it's going to be normal if those two conditions are met. And this is 0.49, and standard deviation is 0.49 times 0.51 over 310. Okay, so we're going to assume that that this is normal, that the conditions are met, and we want to know what's the probability that I get 0.529 since there's decimals or more. What's that probability? P hat is greater than or equal to 0.529. Well, that's again normal CDF, and if you do normal CDF, 8.53%. Okay, I did show the normal CDF calculations on some other videos, so if you just tune in here and you're like, where'd that come from? You can look at some of the other ones, and I actually show it on the calculator. So 8.53%. Is this, let's see here, is this likely to happen? Yeah, 8% of the time you're going to get a sample, your sample 52% or more. Now, is this dangerous to use exit polling? In this case, yeah, because if you did a sample and you're going to get some samples 52.9% that voted for. Well, the real average is 49. This says it fails. This says it passes, because it passes at 50%. So this sample isn't accurate, and isn't very accurate to or close to the true population proportion. Okay, there you have it.